and we already got our data put to X and Y, then I think it's a good time to start looking at our toolbox for machine learning. We're going to use a pretty powerful tool called sklearn, and I think the best way of learning a certain library or certain tool is to go to its official website to look at documentation. Okay, so here you are, we got sklearn and sklearn.org. You can look at their website, and yeah, we got classification, regression, clustering, and dimension reduction, all sort of good a simple tool here. And what we're going to do is to got the regression, because well, we just started and you already know it's a regression, so it's like the reverse engineering sort of mentality, and because you only got X and you want to predict Y, okay, so it's just a simple linear regression. And what I'm going to do is to get the I think the linear regression model. So list linear regression model, quadratic discriminant analysis. Okay, we need to find that, and I think maybe just this ordinary list square, something like that. And yeah, linear model, right? And that's exactly what we are going to use. I think the linear regression model. Okay, so yeah, you can see that, and of course you can always search it here. I think that model's name called linear regression. Let me just search it. Okay, so linear regression. Hopefully it will just give me that. Yeah, linear regression. Yeah, that's exactly it. Okay, so we're going to use this sklearn linear model linear regression. Essentially, just a linear model includes a lot of linear model here, and we're going to use this the simple linear regression model, which is a special case of linear regression. And we're going to get all sort of parameters inside. So we need to get this fit, intercept, copy, x, n jobs, positive or sort of parameter. Essentially, you just need to get this x and y put inside. We already got this x and y single that out, and we're going to get this and all that so the fit, intercept, the copy, and then jobs, all that we can just ignore it, and we just leave it blank here, because the only thing we need to input just the x and y, and they can give us a pretty good fit. And once we got that fit model, we can just use that to do our prediction. Okay, and before we actually jump to that, because a lot of students may tend to just put all this x and y here and just input that. It can work, but that's not the best practice, because you need to understand that the data we got is pretty precious, so we need to make the most out of the data. So we're going to prepare our data to split it, to test and train splits. So I think we can just find it at the official website. So what I'm going to do is to get that train and test split. Okay, hopefully my memory serves me right. Yeah, we got it. So essentially, I'm going to split the array or matrices into random train test subset. So let me grab my pen here, so hopefully I can just write on this computer. Okay, I found a app that can write on it, so let me just use that. Maybe use a sort of a pen like this. Oh, the effect is amazing. So if you are interested in digital art, I got another digital art channel, so you can check that out. For now, let's just use it as a note-taking thing. Okay, so essentially, if you got all sort of the data right here, this is This is your data, and what I'm going to do is to split your data. Okay, so you are not going to use all the data because data is precious. You need the data to test whether you are doing a good job or not. So essentially, you got the part of data, maybe 80% of it, maybe 80% of the data. Ooh, it can move. Maybe 80% of the data that you're going to use it to train your model. Okay, so you use 80% of it and you leave 20% of the data out. Of course, this is real data, so it's reasonable to leave part of the valuable data untouched, because if you put all this into you just split that. If you don't split that, you just extract the x and y out. You put all that into your model, so you use the rest 20% of the data and you overtrain your model. Okay, so in that case, there is no way you're going to check whether your model is good or not. Okay, so you overtrain, so you might get a data that out of your model, that outside the model. For example, you just happen to another person walking with a certain experience or working experience, and you can't predict his salary right because you overtrained your model. Okay, so the best practice is just using most parts of your data, depending on the data size. If the data is pretty huge, you may reduce the testing to say 5% or maybe 1% would be enough, and you use most of the data to train your model. But if the data is pretty small, like this one, you're going to get a much bigger test data. Okay, so in order to do it, because maybe you split that and you got a pretty high number here. Okay, so pretty high, maybe some outlier, or all of these are outlier, and you got a pretty low number here, and you train model, and the model potential predict is pretty high, but when you use number like this, you might not get the pretty satisfactory results. And in order to avoid this, you are going to doing the multiple split. Okay, so you're going to do that multiple times. So this time maybe some data is big, some data is small, some data is big, and we got big and small, big, small, something like that. So it will just if you do that multiple times, you get 1 and 2 and 3, and you do it multiple times, and you just decrease these chances that you get a pretty strange distribution of your training and test split. So yeah, that's the reason why we need to doing the train test split, and you need to specify the test size of the percentage, and sometimes you may need to specify the random state of it. Let's go back to our model. Okay, so we got a model here. Yeah, I think documentation, sorry. Yeah, I got our documentation here. The documentation said that the train test split got certain parameters you need to input with a test size or a train size. Okay, the default is none, but if you input that, it will give you a specific training size. A random state is none, so if you look at the random state, it's an integer, and a random state instance or non-default is none. Controller shuffling applies to the data before applying to the split. Pass an integer for reproducible output across multiple function calls. So essentially, the random state is like a seed that you put, and you got the reproducible. So you can reproduce the results when you say show the model to your colleague or to your classmates. Say, hey, I just got a model, and you need to reproduce that. So you sort of give it a seed, and even though it's random, but it's sort of a pseudo-random. But that's another problem of the randomness, because we can't possibly got the absolute randomness in our programming. So yeah, but that's completely another story. So yeah, let's try to do that. So what I'm going to do is first to split the data. Before we split that, we are going to import the tool necessary to do that. So I think maybe I'm going to write the step, but we're checking. Check non-value. Split our data. Our data to train and test. Yeah, we sometimes call it train test split. Okay, so we're going to use this sklearn and model selection. Import our train test split. Okay, so we can split our data, and we're going to got that certain results as the X training data, and we can use comment to separate it out. So if I got multiple outputs, I could use that to just using one line to solve that. Okay, so this is Python syntax, X train and X test. So we got the X data split into train and test, and of course we got this Y training data as well as the Y testing data. And once we got that, we're going to execute this train test split, because this will return a series of data that we go to store that in multiple variable. Okay, so we input our X. Okay, so X is just X is just to use ilog to find that certain value, and X is something like this. Okay, so it's just years of experience, and Y would be like this, and that would be the salary. Okay, so we input that, and we got this text size, and text size is like you're going to input a I think maybe a float. Is not an integer, it's a float, and you can use, I think, just fairly small number of data. So I'm going to get a fairly large input. Okay, so the text size will be 20%. You can't just use 20. You're going to use 0.2. That's how they wrote this program. Okay, so maybe another person write the program, and they sort of divide what your input is. So maybe you got 20 and they divide it by 100 and do the work. You might be able to just input 20, but for this sklearn library, you need to input 0.2, and you can add random state. Okay, so random state, you can choose whatever you like. Okay, because it's just a seed. I'm going to choose 8, maybe 9. Okay, just for luck. Okay, and yeah, once you got that, I think it's pretty good to get that certain data, and there is no error, which means that it's a good thing. No error, no output is a good thing, because we already successfully store that information into X train, X test, Y train, Y test. If you're not so sure about it, you can just print it out. It's always a good way to print it out. And of course you can just run, and I think it might give you a array info printed out. Okay, and X train, X test, you compare this. Okay, so test would be a pretty small info because you just got 20% of it, but it's a fairly small data set, so you can print everything out. In other cases, you might need to use head to just print the head info. And but for now, I'm going to print everything out so you guys can see the training data is definitely much bigger. It's just 80% of it is training data, the 20% is the test data. Once you got that, you can actually using the fit to train your model. Okay.